We can look and use the trig ratio of sine outside of right triangles. The law of sines gives us, if I have a triangle labeled here, ABC, the ratio of the sine of angle A to its opposite side is equal to sine of angle B to its opposite side and sine of angle C to its opposite side. This ratio exists beyond right triangles. Now, the types of conditions it exists in, we're going to think of it like triangle congruence. Angle side angle will work. So if I had two angles, maybe angle A and C, and I knew the side in between them, I could use that to eventually solve for the other parts. Angle side would be two angles and the side adjacent to them. I could use that to solve for the additional parts. And then angle side works sometimes. Now this doesn't always work, and there's certain conditions that it does not work. This video will not go over those. On all of the cases we have here, they will work and not give us what we call is the ambiguous solution. So it does come up, but that's a little bit later on. And the reason why, quickly, that angle side doesn't work, if I have a triangle where A is acute and A and B are my two sides, A being opposite to A, if A is shorter than B, it can swing in and close the triangle up so it's different and not exactly the same as the original triangle. Now again, that's the brief version of why it works, but that shows why they're not congruent. This would actually give us two different solutions, which law of sides eventually gets to. Now in all of this I've mentioned solve a triangle. Whenever we say solve a triangle, we're going to find all the angle measures and all the side lengths as we solve. Law of sines will be a good start for that. So we start with our first problem. I have angle 104, I have its opposite side, and I have 16, and I do not know its opposite side. So let's go find all the parts. So I'm going to say sine of 104 is to 25 as sine of B is to 16. So that's using my law of sines to set up the proportion. Now with cross product, I can go 16 sine of 104 equals 25 sine of B. Then that becomes sine of B equals 16 times sine of 104 over 25. Now I'm going to simplify this. I'll plug this into my calculator here, and I'm going to do 16 sine of 104 divided by 25 gives me about 6.6209. Okay, so that means then I have, and this is approximation, you'll leave this in your calculator and use it for our next calculation. It's about 6.2099. Now I do sine inverse of that, of this here, to find the measure of angle B. And I have another video where I explain how you do sine, cosine, tangent in a calculator. I'll try to link that to this video if needed. But what we get here is angle B comes out to be 38.4 degrees. So we have 38.4, that's angle B. Now let's continue to find the rest of the parts. Well, if I know two of the angles, 104 and 38.4, the measure of angle A is 180 minus the sum of those two angles. So 104 plus 38.4 is 142.4. So I'm going to subtract that from 180, and I get 37.6 as the measure of angle A. Now for our last step, we're going to do law of sines again to find our missing side. So in this case, I'm going to stay with sine of 104 over 25 because that was the value I knew. And then we're going to go sine of 37.6 is to side BC. We're going to use cross product. We get BC times sine of 104 equals 25 times sine of 37.6. And then we get BC is 25 sine of 37.6 over sine of 104. This is going to go in my calculator. 25 sine of 37.6 divided by sine of 104, and we get about 15.7 as our side, which goes right there. Check, make sure things are in the right place. Largest sides opposite the largest angle, smallest side, smallest angle, we're in good shape. So that was a angle side-side solving with law of sines. Now the next one, we know two of the angles, and this one's going to be a little bit easier. So first off, I can find the measure of angle B is 180 minus 81 plus 33. So I add 81 and 33 together, and I get 114, and I'm going to subtract that from 180. And we get 66. So 66 goes here. Now we're going to write out our proportions with law of sines. I'm going to put all of it together. So we're going to go, so sine of 66 is to AC is equal to sine of 81 is to 26, and that is equal to sine of 33 is to BC. So this middle value, if we think similarity in all proportions, is kind of like a scale factor, a ratio that exists between all of them. So I'm going to do a proportion here and a proportion here that allows me to solve. So in this one, with cross product, we get AC times sine of 81 equals 26 times sine of 66. Then we have AC is 26 sine of 66 over sine of 81. So in our calculator, we get, comes out to be AC is about 24.0. For our other proportion, we're going to have cross product is 26 sine of 33 equals BC sine of 81. We're going to divide and eventually gets to BC equals 26 sine of 33 over sine 81. So we'll go to our calculator. And that comes out to be about 14.3. So BC is 14.3 and AC was about 24.0. Let's keep going. Now, first off, we have angle B. That's going to be 73 plus 42. Subtracted from 180, we get that angle B is 65. Now we're going to have the measure, we're going to go sine of 65 is to AC as sine of 73 is to 34. With cross product, we're going to go 34 sine 65 equals AC sine of 73, which eventually becomes AC is 34 sine 65 over sine 73. And we get about 32.2. Now we can't go in and use Pythagorean theorem here because it's not a right triangle. It would be nice if it was, and we'd use that, and we'd have other methods we'd even solve in that regard. But we're kind of stuck. We have to go back to law of sines. So again, I'm going to do sine of 42 over BC is equal to sine of 73 over 34. With cross product, it eventually rearranges to be BC is equal to 34 sine 42 over sine 73, and BC is about 23.8 for its value. On to our next one. Let's write out our proportions. So we're going to go sine of 56 is to 17 as sine of C is to 14. Now from here I could actually, instead of doing cross product, multiply both sides by 14 and get sine of C is 14 sine 56 over 17. And then I'm going to do sine inverse of that to get the measure of angle C. So with our calculator, I'm going to do 14 sine 56 divided by 17. That should give me about 0.68273, and it keeps going. Now I'm going to do sine inverse of that decimal, and I get that measure C of angle C is about 43.1 degrees. So if that's 43.1, 56 plus 43.1 subtracted from 180 gives me about 80.9 degrees. So that's angle A. Now to find BC, we're going to do sine of 56 over 17 is equal to sine of 80.9 to BC. Rearranging the proportion, BC is equal to 17 sine of 80.9 over sine of 56. So 17 sine of 80.9 divided by sine of 56, and we get about 20.2. Moving down, I have two angles, so 24 and 63 is 87. I can subtract that from 180 and I get 93 degrees. This one I'm going to write out all my proportions, so we're going to go sine of 93 is to 43 as sine of 24 is to BC, so that'll be proportion to solve. Keeping the same one we know, sine of 93 over 43 is equal to sine of 63 over AC. From here I can rearrange my cross product. BC is going to be equal to 43 sine 24 over sine 93. And what we're going to get here for BC is it comes out to be about 17.5. Next one, cross product. Again, we're going to get AC is equal to 43 sine 63 over sine 93. So AC comes out to be about 38.4. So our sides, BC 17.5, AC 38.4. Now I'm not going to work out the rest of them here. What we do need to do though is draw the triangle. So I'm going to draw the triangle, label what we have, and then I'll give you the answers so you can keep trying to work through where you get to them. I think you're kind of seeing the process hopefully as we go through this so far. So first one here, just going to draw a triangle A, B, C. Angle A is 73 degrees. Little a, the crosswind, is 18, and B is 11. So I have to find all of the remaining parts. And what you'll get there is that the measure of angle B is 35.8. The measure of angle C is 71.2, and we get that from just subtracting from 180. And then we do the law of sines again to get that AB is about 17.8. Moving down, we draw our triangle, ABC. A is 26, C is 35, and then B, opposite side to that, is 13. What we'd first do is go in and find the missing angle, so that's the measure of angle B, and that's going to be 119. And then using law of sines, you would get that AB is about 8.5, followed by law of sines again, and BC is about 6.5. For the last one, triangle A, B, C, B is 102, C is 43, and the side B is 21. We're going to find the missing angle first, and that comes out to be 35 degrees. AB, by law of sines, would give you 14.6, and BC, also by law of sines, would give you about 12.3.